Hello, everyone. My name is Rayna, although I do prefer to go primarily by Knox, and today I am going to be presenting my outbreak and recall data analyst. Some info about me. I was born and raised in Louisville, Kentucky, and now live in Nicholasville, just south of Lexington. I have a diverse background in both customer service and in healthcare, and I joined CodeU because I had wanted to learn code to advance my career, but I had no idea where to even begin going about doing so. A coworker of mine recommended the program to me, and I cannot stress how glad I am I took her advice because this has been an amazing opportunity. As I learned, I realized data analytics was what caught my attention the most, which is what leads us to here and now. My project was focused on foodborne disease outbreaks and food recalls. What ultimately led to me deciding to do this was when I was in the process of deciding what I wanted to do my project on, I had heard talks of the FDA and the CDC potentially being defunded around the same time as one of the more notorious food recalls of recent months, namely the radioactive shrimp recall. Food safety is extremely important as the CDC estimates that around 48 million Americans get sick with a foodborne illness every year. That's around one in every six people. The results recalls done by the FDA are done to reduce the amount of harm done to our population, and in the case of food recalls, that does include harm done by foodborne illnesses. My goal was to see if I could find any potential correlation between FDA food recalls and foodborne disease outbreaks reported by the CDC. My thoughts were that if I could find potential correlations between the two, it could be used as a justification to not defund these two extremely important organizations. My data sources for this project were the CDC National Outbreak Reporting System, otherwise known as NORS dataset, as well as the FDA Food Recall Enforcement API. Both are publicly available, and I've included the links to both on this slide if anybody is interested. I'm going to start out by showing some of the visualizations from my project. This one was a bar chart showing what 10 foodborne diseases had the most reported outbreaks. And I found it interesting that while Salmonella had the highest total outbreak count, almost half of the diseases ranked in the top 10 were some variety of norovirus. Here we have a chart showing the number of reported foodborne illnesses each year. And what I find interesting here is that while the numbers typically stayed within the same range, in 2020 there was a sharp decrease in how many reported foodborne disease outbreaks there were. While I originally would have thought that it was because that was when the pandemic first started going in full swing, that doesn't make sense upon further thought, as we were all in quarantine. And since this data is solely focused on foodborne disease outbreaks, that wouldn't have had much of an effect beyond there being less people eating in public places. The values did start going back to normal after that, but it was something I found interesting and would like to look into later on. Here we have another chart showing the number of FDA food recalls per year. Our numbers are pretty even up until 2011, where they go up, and ever since 2016, they have gradually been going down. We do seem to have the occasional spike in numbers, but overall, they have gradually been decreasing since the numbers we had in 2016. This is one of the later charts I made in the project, and it shows the percentage of what diseases were involved in the cases where I did find potential correlations between a recall and an outbreak. Originally, I would have had thought that norovirus would have had the highest percentage, as almost half of the top 10 most frequent foodborne disease outbreaks were some type of norovirus. But this was not the case, as slightly over 82% of the cases with possible correlations between a recall and an outbreak involved salmonella. I had several challenges going into this project, most of which I had already been anticipating. These were both very large data sets with tens of thousands of rows each, and as such, it took a lot of time and effort to clean my data. Additionally, I had multiple columns where the data values were inconsistent, with one example being a column in my NORS dataset, where looking at it initially, you would expect all of the values to either be confirmed or suspected, and instead I had several rows where the value was some combination of the two. And I had to be very careful in how I ultimately fixed those values. The solution to getting everything cleaned in time for me to do a proper analyst was by getting so into the groove of coding that I ended up hyper focusing for 48 hours straight on fixing the worst of the inconsistencies. To start out with, I had to gather my data. The NORS dataset was pretty easy as I was able to just download the CSV file from the site, but the recall data was a bit trickier. I ultimately created a function to pull the data from the API and turn it into a CSV that I could work with from there. And you can see a line from that function where I used the time.sleep function to ensure that I wouldn't accidentally hit the request per minute limit by adding a short pause between those requests. As I mentioned earlier, there was a great deal of data cleaning involved in this project. For one, I had to standardize the date format so that I could later join both data sets on the dates. I also had a large number of inconsistent values, and you can see here part of a function I made to handle that. I had made a list of rules in order to correct and standardize values to the best of my abilities. And this part of the function ensured that once a value in that column had been corrected, the function couldn't edit it again. And it even standardized the values that didn't fall under my rule list by giving them a general label of other. From there, I used SQLite to normalize the data from both my data sets into relational tables so I could begin analyzing and visualizing. I will admit that there were limitations to my project. For one, my data is highly reliant on what was reported. There's always going to be the chance that a recall wasn't input into the API correctly or that an outbreak didn't get reported. There were also constraints about in gathering the data from the API. With the function I wrote, I was only able to gather around 26,000 rows due to the limitations within the API. And I know there was more data within the API that I wasn't able to gather with my function alone. The final limitation to this project was that this project was focused entirely on correlation. While I would have loved to have find some type of causation and get a definitive answer, I knew there was no way to do so. And we all know the phrase correlation does not equal causation. With that, this is the end of my presentation for you all today. Here are the links to my profiles on other platforms in case you guys are interested in anything else I've worked on. Thank you all so much for watching, and I hope you have a great rest of your day.